but the decimal is absolutely okay. All right. $17. The first four terms of a sequence are given. This is 2, this is 9, this is 40.5, and so on and so forth. It says, what is the next term in that sequence? So we have to figure how much is it going up by. This is a geometric sequence because it's not going up by adding or subtracting the same number. It's going up at a more rapid rate. It's going up by multiplying, okay? So in order to figure out the common ratio or the number that's being multiplied to get to this number right here, we're going to work backwards and divide. So here what we have, we can say 9 divided by 2, and we know that that's 4.5, okay? So our common ratio here is 4.5, all right? So we have to multiply by 4.5 to get the next number in the sequence. So we can type in that 182.25, and we multiply it times 4.5, okay? And then that's what we get right here. So the answer is going to be D, okay? So here's going to be D. Okay, an arithmetic sequence is shown below. All right, we got 5, 1, -3, -7. So look, guys, this is going down. All right, so how is it going down? How do I get from 5 to 1? Okay, to get from 5 to 1, all I did was subtract 4 here. Then I subtracted 4 to get here. Then I subtracted 4 to get here. So this is an arithmetic sequence. This is linear. Arithmetic sequences are linear. Okay, so not using the word common ratio is common difference. When it is the number that you add or subtract to get to the next term is called the common difference. So my common difference here is going to be that negative 4. So since my common difference is -4, that's also my rate of change or my slope, my m. So for 18, remember the equation is y equals mx plus b if it's linear. And my m, or my common difference, is going to be a -4, okay? So now I have to find the starting amount. Well, this is the first number that they give me, the second number, the third number, the fourth number. We know that in order to get this very starting number, we're going to work backwards to get what this number was before. If you're subtracting by 4 this way, to work backwards, you're going to add 4. So when I add 5 plus 4, that gives me 9. So my starting amount is going to be 9, okay? Starting amount is going to be 9. So then the equation here is going to be -4x plus 9. So that's what I'm going to look for. And I got -4, and instead of using x, they use n. That's fine. Plus 9. So that's going to be my equation there. So my equation, the answer for 18 is A, okay? All right, number 19. It says a ball's height over 4 bounces, okay? So this is the bounces. This is the number of bounces, and this is the height, okay? Assuming that the trend continues, okay, what is the approximate height after the 10th bounce? So here you look at your numbers and you look to see what kind of pattern you think that it might be having. And again, in our last example, we know when the ball bounces, we remember it was an exponential function because it bounced at a half. So here, a ball bounce, we have to think about it. A ball bounce is not going to be linear. It's going to be exponential decay, okay? So we're going to type this in our calculator. Clear it, second plus 712, easy reset. And we're going to go to Stat, Edit, and we're going to type in our number of bounces for X. And we're going to type in our heights for Y. remember this decimal is 0.25. Or I'm going to show you how you can type in this fraction part. When you type in the whole number plus the fraction 1 over divided by 16. You can type it in just like that, okay? And it'll convert it as a decimal for you. All right. So now we're going to go to Stat, Calc, and Exponential Rig. There we go. All right, I want this to go into my y equals, so I don't have to write it and then type it under y equals to find the 10th number from my table. So I'm going to press second, 1, comma, second, 2, comma. Then remember I got vars, y vars, and I press enter 3 times. Function, y equals, and then get the answer, okay? So that's what we have there. So go to y equals, and the equation is there. So now we want to view the function table so we can find the 10th bounce. Function table. So we go down to 10. And this is our 10th bounce here. 115.81. So the closest answer is 116. So 19 is going to be 116. Okay, it says Mr. Levy invested $6,500 at this rate, okay? Annual interest rate. So interest is only being charged once a year. It says the function, and this is the equation right here, models the value of the investment after t years. What is the value after 18 months? So we can plug in, let's see. So if t is in if t is written in years, we have to convert 18 months into years. So we have our calculator, and we can do this in our head, but I'm going to do it in calculator. You have your 18 months divided by 12 to figure out how to convert, or how many years is 18 months. When you divide, that gives you 1.5 years, okay? So our t is 1.5 years. So when we do this, and we type this into our calculator, this is what we type. We have, and then our t is going to be that 1.5. So this is what we can type in. Don't forget the equals, Reyes. All right, so we have 500 parentheses 1.045, and then look, parentheses, caret key 1.5. Okay, and so that's what we have there. So our answer is going to be, the closest answer that we have is this one right here, 6,000. You see it almost exactly right, okay? They just rounded to the nearest hundreds place because we're talking about money. So this is going to be B, $6,943.65, okay? 21. It says the function, and this is the equation right here, okay? Where models the value of the car after 2010. This is exponential decay because b is less than 1. What is the approximate percent decrease in the value of the car? Okay, from previous years, if you remember, percent of change, not rate of change, but percent of change formula, percent of change formula is old minus new over old, okay? So this is the formula that we're going to have to use. So the old amount, or the starting amount, is this. So that's going to be 21, okay? 21,900. And the new amount we have to find, that's 5 years later, So reset. Type this equation in. 900 parentheses 0.91 caret key x. Okay, so we got that typed in. And now we want to go to our table. And we got 5 years later. Okay, let's go down to 5 years later. It's 13,666. So that's our 5 years later, the new amount. So that's minus $13,666 divided by the old amount. This is how we find the percent. Okay, so now we're going to do that. Main screen, and it's 21,900. I could have just put all this in parentheses instead of doing 2 steps, right? 21,900 minus 13,666. Okay, and then on the divided by 21,900, right? Did I type in that right? Yep. Okay, so that's going to be 0.375 as a decimal. So move it over twice, and this is 37.5%. So the closest percent is going to be the B, 38%. So my answer here is B, 38%. Okay. All right, so now the rest of these, we kind of know how to do this. I'm going to skim through some of them because I've basically ran out of my time. Here, remember, this is the same as y is equal to 4 to the x power. Automatically, the number for a, if you don't see it, okay, that y-intercept, because remember, the form is a times b to the x power, and you see how the a is missing? It's automatically going to be 1. So if you don't see it, it's automatically 1. Okay, so that's why it's b there. Here, to find the rate of change, you have to use the formula y2 minus y1 over x2 minus x1. And you only have the x value, so what you have to do is type in this equation and figure out, or you can find your y values by just plugging in the x values, okay? So we have here, to find this one, that y is equal to, we're going to find the first x is equal to 2. What is my y here? Okay, slide this over a little bit. What is my y here? So we're going to plug in 2 to this equation. So that's 15 times 1.5 seconds. So let's type that in. 15 times 1.5 raised to 15 to the second power. So your y is going to be, for this one, 33.75, okay? Make sure I type that in right. Boom, boom, boom. Yes. All right, so the other one, the x value is 5. So when you do this one, you have to figure out what the y is again. Slide over a little bit. So we got 15 times 1.5 caret key. This time it's going to be 5, okay? Sorry, y'all. And so my y value is going to be 113.90 or whatever. All right, so we have to figure out what the rate of change is from both of these. And I could have actually did this. I could have typed it in, y equals, and I could have said, it probably would have been faster, who knows. There's so many different ways to do these problems. Sometimes when you start doing it, you realize, oh yeah, I could have did it this way, you know what I mean? All right, so go to my table. Yes, probably would have been easy, right? And go to 2, and we got that right, 75, and then go down to 5, and it says 91. I put 9, but 91 rounded, that's decent, okay? So now you have your 2 ordered pairs, and when you have your 2 ordered pairs, guys, remember that all you're doing is using the slope formula, which the slope formula is the same as the rate of change formula. So here, your y2, this is x1, y1, x2, y2. Your, remember, first order pair, second order pair. Subscripts just tell you that there's more than one x and more than one y. This is the first x and y, this is the second x and y, okay? So here we have 13.91 minus 33.75. And on the bottom, we have 5 minus 2, okay? Right? All right, so this is 113.91 minus 33.75, okay? And that's this. This is going to be 80.16 divided by 3, okay? So we're going to divide it by 3. And this is 26.72. So 26.72 is about that 27, okay? All right, so here again for this one, it says select your answers. And didn't put it all on there, did it? This is, you got f of g equation is this. F of x equation is this in the table. So guys, look, if you want to find the equation for this, type it in under exponential reg, okay? And then it's asking, then you just compare them. Write down what A is for both of them. A for this one, starting amount, or the y-intercept is going to be 1, remember? And my B is going to be 2. You have to do the same thing for that, but you do exponential reg. You can do that part on your own. 26, they give you an equation, okay? And you have to figure out what that rate, what does this right here mean? Remember, this is my common ratio. B is less than 1, so the equation that you use is this to figure out what your percent is, okay? But this is my common ratio. This is my growth factor. But to figure out my percent, I type in, not type, Lord bless me. I substitute and I subtract. And so this is going to give me a negative 0.2, right? And then I divide by negative 1, okay? And so this is going to be 0.2R, which is 20%. And this is a 20% decrease, okay? So the decay rate is decreased. If they said that this was 0.8 was a growth factor or decay factor, that would have been correct, a decay factor. Okay, but if they want to know the percent, it's 20% decrease. So that's going to be C. All right, and we have gotten that wrong in the past. You've gotten that confused, okay? And let's see here. You can do that in the table. You just graph those and see which one. I'm not going to go through all of that. Which best describes the, okay, depreciating at a certain time. You can do this too. You figure out what the percent is by what I did on the previous page just now. This is your starting amount. You should be able to figure that out. It's going to be exponential growth, okay? It's appreciating, so you can mark out these two because it says depreciating, okay? So you got those, so that's easy for you. All right, you can figure that out by just using B is equal to 1 plus R and plug it in. This, okay, and then figure out what the percent is there. All right, so that's how you do that. So look, guys, these are the answers, okay? These are the answers here. So if you missed something, then you can pause the video and kind of see what your answers are, all right? Love you. Have a great day.